Welcome back to the 10th part of Debugging at Scale, where we venture into the dark corners of your code and know exactly where to look. In the next few videos, we tackle the scientific method that underlies the debugging process. We will also discuss the methodology we should follow when tracking and fixing bugs. By following this process, we can shorten the time spent debugging. Debugging is a bit like Alice in Wonderland. It's about observation, curiosity, experimentation, and adventure. Yet, I often get the sense that people don't enjoy debugging. Antagonism towards debugging stems from the frustrating nature of the process and often cringe-inducing results. In my experience, most bugs are stupid. As we resolve the debugging process, our most common response is a groan. How did I miss that? This is normal behavior, but it results in shame. That plays to inadequacy and imposter syndrome. I can attest that after 40 years of programming, my bugs are still just as stupid. I usually say that there's a universal debugging gesture. It's the facepalm. I relish this feeling. It's humbling, a humbling feeling that keeps me grounded. Without that feeling, my ego might have inflated to unimaginable dimensions, destroying my relationships with colleagues, family, and friends. It's a form of meditation. I feel that some CEOs should use debugging as a meditative process that would keep them grounded. This is the process we need to follow when tracking a bug. We first search for the responsible area in the code, search the documentation, and do basic research. We then formulate a game plan to address the bug. This is an important step we often skip in our rush for the fix. We make assumptions, but we don't structure and list these assumptions. We work without an organized, premeditated strategy. We need to plan, make assumptions, and validate those assumptions. That's all part of the game plan. We need to isolate the behavior and try to get a consistent test that we can use to reproduce the problem. Ideally, this should be in a local environment in the debugger. But if we can't get a consistently reproducing bug, we can never know for sure if the fix we made is correct. That doesn't mean we can't fix such bugs, but it would mean that the process will be harder and fraught with uncertainty. Next, we should verify that the results of the tests and environment match our expectations. We made some base assumptions in the game plan, and when isolating the issue, we need to verify that these assumptions are correct. Typically, we would expect two forms of verification, since one can be flawed. I'll discuss that more in depth later on. Next, we need to eliminate the impossible. Arthur Conan Doyle wrote that once you eliminate the impossible, whatever remains, no matter how improbable, must be the truth. This is the point to Sherlock Holmes' The Problem. We can eliminate possibilities in many ways. One way would be commenting out code to observe the impact. But there are many ways in which we can eliminate possibilities until we end up with the only obvious option. After the elimination stage, we should understand the bug. At this point, we should use that understanding as part of the issue resolution process. The issue resolution process is a standardized system for resolving issues. It includes filing an issue, creating a test case that fails, verifying the proposed fix resolves the test case, and committing both together. I'll talk a bit more about this process later. But first, I want to talk about something else. It's often said that 5 hours of debugging can save you 5 minutes of reading the docs. This is wrong. I want to be clear here. You should read the docs when applicable. You should know the platform and system you're working on. That's part of why that saying sounds right to most of us at first glance. Every single one of us spent time debugging something only to find out that the bug was due to misuse of an API that might have been documented. I think this makes some sense for students, which is why academia is so different from the real world. When you're given an exercise, you need to read it properly because the clues are there. But a real world problem rarely has the solution inside the docs. More importantly, which documentation should we read? For the API or platform we use? There's usually many volumes involved in that. For the system itself, the user manual, the developer documentation, it would take us more than 5 minutes just to decide where to start on a typical system. So, no, reading the documentation is complete bull, but it does lead us to the first stage, and that's searching for the problem. When I learned to code, there was no internet. Google was founded years after I got my first job. For the majority of my professional career, there was no Stack Overflow. Both of these completely changed the way we debug. We can take more error messages and paste them into a search engine. A lot of bugs start and end at this point. It's truly a revolution. The main challenge is phrasing the search terms and revisiting this as we progress. The initial problem might elude us, but if we make some environmental changes, we might get a different error that might be more friendly to search engines. Obviously, don't take every answer on face value. There's a lot of bad advice online, but this is often a good start. Many years ago, I was trying to track an issue with the wrong number of elements in the results. I didn't use any method or strategy. I felt confident I'd find it. 2 days later, it all boiled down to a greater than character that was facing the wrong direction. Impatience cost me 2 days of work. Had I worked patiently with an organized game plan, I would never have wasted so much time. So our strategy moving forward depends on the type of issue we're dealing with. Ask yourself the following questions before proceeding. First, is this something the user can reproduce? Is this something that you can reproduce on your machine? Does this issue happen consistently? Is the issue a regression? If the issue is a regression, and ideally you can reproduce it, I suggest checking out the section on Git bisect, which I'll cover when discussing tools. It will let you narrow down the specific revision where the issue first appears. If you can't reproduce and then see the bug, we already have an important data point. The bug itself might be incorrect. External factors might be the cause for the issue. Something like a plugin on the end user machine. This should enter your list of assumptions. At this point, we need to make a game plan. There are two different paths you can follow to debug, and they vary based on the answers of before. In the next video, we will continue the discussion of the game plan, focusing on debugging issues that we can't reproduce first. If you have any questions, please use the Slack channel to ask them. Thank you.